Okay, we're going to look at the law of cosines right now. And the law of cosines is another time to use trig when you don't have a right triangle. If you think about the law of sines, in order to use the law of sines, you need an angle and the side across from it. What happens if you don't have that? What if you had three sides or this angle and these two sides? You couldn't use the law of sines. The law of cosines is going to help us. This one's a little bit more complicated to derive, so follow along, take notes, pause it when you have to. Make sure to jot down any questions you might have, things you didn't understand. Okay, so if you look at how we have this written, here's our height. We're going to call this little section R. And then this whole thing is B minus R, right? Because this is B, right? This is B. Okay, what we're going to do is we're going to write the Pythagorean theorem a couple of times. We're going to say that r squared plus h squared equals c squared. And we're also going to say that b minus r squared, quantity, plus h squared equals a squared. Okay? That should make sense from these two little right triangles, right? These are two little right triangles because this is an altitude. Okay, we're going to solve each of these for h squared. Notice these parentheses, they're really important. Okay, at this point, we have two things equal to h squared. So we're going to set them equal to each other. So we're going to get this. Okay? Alright, we've written this, we're on a new slide, so we have more room. I'm going to now start simplifying this. So we'll multiply this out. And we get this. If that, you're not sure where that came from, you need to talk to a teacher. Okay? Now when I distribute that negative sign, this is what we get, minus r squared, so pay attention to those negatives. What that does is get rid of this r for us, right? Okay. Now I'm going to go ahead and solve this equation for a squared. A squared. And it's okay if you don't know why I'm doing this. What I hope you understand is how it works. Okay? C squared, and I'm going to add b squared, and I'm going to add 2br. Okay? Now we're going to take a little detour and we're going to think about r. If you look at this, the cosine of a is equal to r over c. If we solve this, c times cosine a is equal to r. So we're now going to substitute this in for r. So we're going to end up with plus b squared. Oh, I'm sorry. This should be a minus because that should be a plus. Does that make sense? That's my fault. Distribute the minus. You get a plus, and then when you move it to the other side, you get a minus. I apologize. Minus 2 times b, substitute in c cosine a. So here's what we have at our final product. Okay, this is the law of cosines. Okay, if you notice, if you have the three sides, the only unknown is an angle. Or you could have the angle and the two sides next to it, and the unknown would be the side across. So that's why this will work when the law of sines doesn't work. Okay? We could just as easily rewrite this with the other letters, right? The letters don't matter because we could change it. What I want you to notice here, this side, this is the angle across, and the other two sides are here. Okay, so take a second, see if you could finish this equation for the law of cosine. Push pause and try it. So if you did this right, you'll get something like this. Okay, and we know about commutativity, so if these you have in different places or these, that's fine. And that's the law of cosines.